Hi everyone, welcome back to my series on SVG, Scalable Vector Graphics. This is part 3, introducing paths, the path element. A little bit about me. My name is Rob Larson. I'm an experienced front-end engineer, author, and open source contributor. I'm co-author of Professional jQuery. It was my first book. It was a long time ago. I'm the author of Beginning HTML and CSS, the author of The Uncertain Web from O'Reilly, the author of Mastering SVG, which is, of course, pertinent to this series, and co-author of the HTML and CSS workshop. I'm a long-time open source contributor. I currently maintain HTML5 boilerplate, and I administer the H5BP organization on GitHub. And I share other open source projects, some of my own, some of which have to do with SVG. So check it out if you are so inclined. So what will we cover today? First, we're going to talk about what the path element is and why it's the most important element in SVG. We're going to talk about how to read the commands in the powerful D attribute of the path element. And then we'll look at all of the commands for moving, drawing lines, and creating curves that you can use with the path element. The path element. So by far, the most important element in SVG is path. Path lets you draw virtually any line or shape using a series of vector commands passed to its D attribute. If you're doing anything complex in SVG, you're almost certainly using a path. The path element's difficult syntax, and it is difficult, was a significant barrier to early SVG adoption. Now, obviously, the browser mattered a lot. You needed to be able to run SVG in the browser. But if you were sitting down with a browser that was capable of rendering SVG and you looked at the path element, you had to do some figuring things out, for sure. The values in a D attribute can be incredibly dense and complicated, making it the hardest part of the spec to work with manually, and no one does work with it manually. The good news is, like I said, you really don't have to. Complex paths are almost always generated by design software or helper libraries, JavaScript, etc. That said, if you're working with SVG and you want to get serious with it, understanding the basics of paths is foundational to understanding SVG. So here's this video. So how complicated can they get? So you want to see an example? I'll show you one. Let's look at the code used to render the S in the SVG logo. Without knowing what's going on, and take a look at this. Without knowing what's going on, that's impossible to parse. You can't really figure it out. There's all this shorthand. The syntax is kind of odd. There's actually a quirk with the syntax, which I won't talk about here, where spaces don't matter in certain instances, which would drive you crazy. So yeah, just don't even try and figure it out. But even knowing the rules, like after you watch this video, you can go back and take a look at what's going on here and try and figure out what's going on. You could piece it together pretty well, but it's still very difficult. It's just not meant for human consumption, which is really the issue. But there is a logic here. There is, and we're going to go through it, which is why you can write tools to make SVG happen, right? To make the magic of SVG happen, you can write the tools because you just take the rules for the D attribute and you pass whatever you need into it. You make calculations, and there you go. You do some math, and it's fun. But, you know, like I said, no one is authoring paths by hand, or maybe simple ones, but really, if you're doing anything complicated, you're using a tool. This is in direct contrast to other SVG elements, which are no more complicated than their HTML counterparts. We'll be looking at many of those elements in the next video in the series, and actually subsequent episodes. I'm going to be talking about, you know, much more straightforward SVG elements that you can render by hand. But we're going to look at path now. We're focusing on path. So let's take a look at a simpler example to gain some understanding of the way that paths work. A path you can follow. Let's look at some source code. All the source code, again, is on GitHub. I didn't mention that earlier. I will mention it again at the end. But, you know, if you want to follow along, you can go on, link in the description. You can go on GitHub, take a look at the code, play around with it, edit it, go nuts. That's what it's here for. So here's an example. It's simpler. Hopefully you can get your head around what's going on. There's only 2 commands that really matter. The third is very simple. You'll understand that in a second. So in this document, this SVG document, we're creating a simple half circle. So these are the command instructions passed to the D attribute of the path element. M100 space 200. How's that read? Move to, M stands for move to, 100, 200. So that's in the plane of the SVG, which we learned about in the last episode, last video in this series. You learned about the plane, starts at 0, 0, and moves left, left and down. So it's 100 over, 200 down. And so we're going to move to 100, 200. That indicates the path will start at that point. This sets the starting position for the drawing. So if you like have a pen, you've put the pen at 100, 200. Now you start passing more commands to SVG, and it will draw from that moment on, from that position on the canvas. C, 150, 350, 300, 200. Okay. That's arcane. C creates a cubic Bezier curve. The curve starts where we had inserted the pointer, where we put the pen at 100, 200. The first control point is at 150, so up and to the left of where we started. But I'll talk about control points in a minute. The second control point is at 350, so up and to the right. The curve ends at 300, 200. This creates a smooth arcing curve from the left to the right, passing above the starting and ending points. So it goes like this. We'll see it in a second. And the final command is Z, which closes the path. It draws a straight line from the current point, so we've ended at 300, 200, back to the starting point, 100, 200, closing the shape. There's other ways that you could draw that line, but Z just closes the shape, which if you're doing drawings, you'll realize you haven't used Z because the outline won't go all the way around the drawing. So useful. And here's what it looks like. It's very simple. It's a half circle. It's purple. It's blue. This is what the previous instructions drew. Okay, if you're not familiar with Bezier curves, if you're wondering about them, you're in luck. I'm going to briefly describe them. They are named after Pierre Bezier, an engineer at Renault, the car company, the French car company, who was a pioneer in computer-aided design. So he did a bunch of stuff, helped design cars, etc. And if you're doing computer-aided design, or any design really, on a computer, you've run into Bezier curves because they're fundamental to drawing curves in a way that computers can understand and replicate. So let's define them. In SVG, a Bezier curve is a smooth, curved line defined by a set of points. We've already seen this, but we're going to go into a little bit more detail. These points are not all on the curve itself. So we talked about these. Some act as control points that influence the shape. There are two main types of points used to define a Bezier curve. Anchor points. These are the start and end points of the curve. The curve will always pass directly through these points. So these points are on the curve. Control points. These are points that are not on the curve itself. They act like magnets, and I'll show you what that looks like in a little bit, pulling the curve towards them and defining the curve's shape, its direction, and its steepness. Think of them as handles you can pull to bend the line. And again, I'll show you an example of what this looks like in a second. So how control points work. The position of the control points determine the curve's tangent, the direction of the line as it leaves an anchor point, and its magnitude, how far the curve bends. The line between an anchor point and its corresponding control point sets the initial direction of the curve. The distance of the control point from that anchor point determines how much the curve bends. The control point further away creates a more pronounced, steeper curve. Keep that in mind. Keep all of those descriptions in mind because I'm going to show you an example where you'll see the curve bend depending on where the control points are. I'm going to give you an illustration of control points. There are two kinds of Bezier curves. So I said there was a cubic Bezier curve. There's also a quadratic Bezier curve. The defining difference between the two kinds of Bezier curves are the number of control points that shape the curve. A quadratic Bezier curve is defined by 3 points, a start point, an end point, and a single control point. A cubic Bezier curve, remember we had two arguments other than the end point. A cubic Bezier curve is more complex, defined by 4 points, a start point, an end point, and 2 control points. The defining difference between the two kind of Bezier curves are in the number of control points, as I just mentioned. But what does that mean? Well, a quadratic Bezier curve with only one control point can only form a simple parabolic arc. The single control point pulls the curve toward it, dictating the bend, direction, and magnitude. This simplicity makes them easier to work with, but limits the variety of shapes that they can create. They are always segments of a parabola. A cubic Bezier curve is more flexible. With 2 control points in a cubic Bezier curve, you have significantly more control and flexibility. The first control point influences the direction of the curve as it leaves the starting point. The second control point determines the direction of the curve as it approaches the end point. The distance of these control points from their respective endpoint affects the curve's curvature. This allows for the creation of more complex and nuanced shapes, including S-curves, which are impossible with a single quadratic curve. So here's a demo. There's a link in the description for this code. This will allow you to play with control points to get some sense of how they work. If you've done work in a vector graphics program like Illustrator, this will be more familiar to you, and the way control points map to the shape of the curve should make some intuitive sense. If you haven't done any work in Illustrator, this demo will help you see the relationship between the control points and the shape of the curve. So let's run. I'm not going to do the live demo. I'm just going to show you a video, but let's run that video. And so you can adjust up in the top of the thing, you can adjust the control points up and down. And as you can see the magnetic relationship between the position of the control points, which are the red dots, and the shape of the curve. And actually, if you play around with the demo, here's some homework for you. If you play around with the demo, you should be able to create an S-curve, right? So take one of the points and bring it below the line, the baseline, and you'll be able to create an S-curve, which, again, you can't do with a quadratic Bezier curve. And here's the simpler demo showing how a quadratic Bezier curve works. And you should really be able to see how the relationship between the control point and the curve works with this example, because it's a lot simpler. You can also see how it might be easier to work with because there's only one point that you're dealing with, but it obviously offers less flexibility because you can't create that kind of X curve, which is, part of making complicated shapes, is to be able to, move things around in a much more flexible way. The Path API. Okay, so while the audience for this series is by definition people getting started with SVG, it's an introductory series, you're probably unlikely to jump in and script complex path elements. That said, I would be failing at my job as an educator and someone that's interested in technology and sharing what I know about technology without at least defining what you can do in a path element. I will actually return to the path element later in this series because I'm just going to keep going and talking about SVG until I'm sick of it, which is probably never because I really do enjoy it. So I'm going to return to the path element later on in the series, but we'll be well beyond the kind of introductory topics at that point. So for now, a brief overview is likely all that you will need. For most of us, awareness of what tools like D3 are doing under the hood is probably enough. I mean, to be honest, I've never had to do any in-depth debugging with a path element directly when using modern tools. I'm just working with the tool itself and trying to figure out what's going on. Command instructions. Okay, so a key concept to remember is that each command instruction comes in 2 forms. Uppercase, that uses absolute coordinates, meaning the points are positioned relative to the SVG canvas's origin. Lowercase uses relative coordinates, meaning the points are positioned relative to the previous point in the path. You can do both of these make sense at certain times, and you can start to imagine use cases for each version. We've already seen this one, command instructions move to. This command moves the pen to a new location without drawing a line. It's used to start a new subpath. So uppercase M, absolute, moves to the coordinate X and Y. Lowercase m, relative, moves by X horizontally and Y vertically from the current position. Command instructions line to. These commands draw straight lines from the current position to a new position. Lowercase l, relative. This draws a line from the current point to a point X and Y pixels away. So you don't necessarily need to know where the endpoint is. You just need to know how far up and how far over you want to go. H, horizontal line to, draws a horizontal line, the capital H, absolute, draws a horizontal line to the X coordinate. H, relative, draws a horizontal line, not to a specific X coordinate, but you just give it a length. Same thing for vertical. So vertical line to, the absolute version, uppercase V, draws a vertical line to the y coordinate y, so a specific point. V, relative, draws a vertical line y pixels long. And again, you can start to think of where there would be use cases for each of these, right? You're drawing a map, and you know that there's a pixel, there's a pixel that you want to hit that represents New York City. You maybe want to draw a line to that specific pixel coordinate. If you're doing a drawing and you know that you want to go up and to the right 50 pixels and 75 pixels, but you don't care where it ends up, that's where you would use a relative version of these tools. Command instructions, curve to. So these Bezier curves, these commands draw various types of Bezier curves. Uppercase C, cubic Bezier draws a curve to x and y using x1, y1 as a control point for the start of the curve, and x2, y2 as a control point for the end. S, smooth cubic Bezier. This is a shortcut for stringing cubic curves together. It assumes the first control point is a reflection or mirror image of the last control point used in the previous C or S command. x2, y2 is the second control point, and xy is the endpoint. Q, quadratic Bezier, draws a simple curve to xy using only one control point at x1, y1. T, smooth quadratic Bezier. This is a shortcut for stringing quadratic curves together. It assumes the control point is a reflection of the control point from the previous Q or T command. So again, it's a mirror of the previous control point that you used to define your previous quadratic Bezier. And again, we'll revisit paths and Bezier curves later on in this series. It's really interesting. It's really fun stuff. But we're in the intro phase. We're in the intro phase. We're going to stay on target. And really, you can do a lot with SVG. You can be a professional with SVG, letting tools handle this stuff. I mean, if you really want to get deep and do super custom stuff, it's where you're going to have to code some of this yourself. Even on top of like powerful tools, you may have to do something custom yourself. But for the most part, you can do a lot with SVG, just allowing tools to handle paths. But knowing what's going on is important as you learn more about SVG, especially if you're writing custom tools or visualizations. And so now you at least have a foundation on the paths D attribute. So what have we learned? Okay, some key takeaways. The path element is the most important element in SVG, allowing you to draw anything using vector commands. Path instructions are passed to the D attribute, which can be dense and difficult to read manually. We can create shapes by using commands like M, move, line, L, and C, cubic Bezier curve. Complex paths are generally generated by software, JavaScript or Illustrator or something like that. So understanding the syntax is important because it's foundational, but you will generally use tools to generate paths. Thank you. If you haven't yet, please subscribe, like, share with your friends, comment, let me know what you think. Let me know if you have any questions. I'm going to continue to work on these because they're a lot of fun for me. And like every one of these videos I do, I learn something myself or I approach something differently, which is fascinating because I wrote a whole book on SVG and I've already looked at some of the material I did back then and thought, well, I could do that better. And that's what you're getting now, is you're getting the better version of some of the thoughts that I had in 2018 when I wrote that book original. So as I mentioned, the code and slides are on GitHub, free for you to use. LinkedIn, you can reach out to me there. You can follow me on GitHub. I have a blog that's kind of coming back to life, which is fun. And yeah, so I'm hoping I'll see you in the next one when we talk about more SVG elements, ones that you can really actually author by hand, which will be fun. And yeah, I'll see you then. Thanks. Bye.